Good morning. My name is Rachid Guerraoui. I'm one of the professors of the School of Computer and Communications at EPFL. As you probably have heard or read, this has become one of the best schools in the field in the world. And I really hope you will join this great school next September. If you join the school, you will be working with a couple of professors in September, and then eventually join one of the professors of the school for the year after. And I'm one of those, and I'm going to tell you what I do and what my group or my lab called the Distributed Computing Lab at EPFL does. So we work on robust distributed computing. Forget robust for now. Distributed computing is today almost every computing. Every program today works either on a large scale setting deployed over machines in the cloud, or even locally on a bunch of processors, and usually both, deployed over a large-scale setting, and every piece of the program that runs locally runs on several processors. This is distributed computing. What we call robust is the ability of the program to work properly, even if a subset of the processors and the machines on which the program is deployed do not behave well. Either they're slow, or they're bogus, or they're using bad data, or what have you. And this is crucial. Many computing applications today are critical, and most of them are distributed. So I believe that robust distributed computing is something very important. So I'm going to give you 3 examples of these that we have been working on recently. Of course, there are other examples that we were working on before, and we don't restrict ourselves to the 3 examples I'm going to give. But let me give you these 3 examples to illustrate what the field is and what you could be working on if you join my group. The first example is the Bitcoin protocol. You probably have heard about it. Some 10 years ago, somebody, whomever that is, Nakamoto, wrote this very genius algorithm to enable nodes of a distributed system, behind these nodes users, to send money to each other in a secure manner. So I could send you money, and you can trust that the money is safe in the sense that I really have it, and now you really own it. And the problem solved by Nakamoto is that of preventing double transfer. And there have been the protocol by Nakamoto, and then hundreds of them. What is that we did in my group? We looked at the problem as defined by Nakamoto very precisely a couple of years ago, and we realized that I would not say that the way Nakamoto and others solved the problem is wrong, but it is unnecessarily complicated. They tried to solve a notoriously difficult problem in distributed computing called consensus. And in retrospect, we understand now why all those solutions and protocols that have been proposed are not very fast, or not very efficient, or not very frugal. They consume a lot of energy, they need a lot of messages, etc. And this is because they solve consensus. Essentially, they want all the nodes of the system to agree exactly on a total order according to which all transactions and payments will be ordered. And we could prove that you don't need to solve this consensus problem in order to enable secure payment. So we proved that theoretically and then empirically. So we wrote some papers that are theoretical and others that are practical. This is something we still work on, and we address both the permissioned case and the permissionless case. And many students are working in this direction for future digital trust environments that would not consume as much energy messages as we see today. So this is a very promising area, and we have been working with many industries and partners all over the world. So this is something you could do if you join the group. There are many open problems that are still there, both from the theoretical and the practical side. Let me give you another example, which is also quite hot. Machine learning. The key to the success of machine learning, one of the keys, is data. And in order to be able to tackle a large amount of data, you basically need to distribute your program. And the usual or the typical distributed environment today is the parameter server environment. You have one machine called the parameter server that basically maintains the model you want through which you learn. And you have a bunch of workers that compute some gradients typically and send the gradients back to the parameter server, which averages. So averaging is good if all workers behave properly. But just think of a simple example of averaging temperatures. If all workers are working fine with good data, no bug, no nothing, they will send you for human temperatures between 36 and 41. Averaging them is reasonable. But if one of them is bogus and sends you back 1,000, of course you can say it's too much, but just to understand, the averaging will be very bad. So averaging is not robust. So we have been working and we were the first to propose robust alternatives to averaging. So again, we did the same as for Bitcoin and blockchain. We published some theory papers at NeurIPS and ICML, and then some practical papers showing how you can do robust distributed machine learning. And very recently, we addressed a complementary question, which is, what if you cannot trust the parameter server either? Or what if the parameter server is actually a bunch of machines that are collaborating to learn together? For example, in the federated learning world, or simply in a critical world where you don't want to trust one parameter server. And this turns out to be a very, very difficult problem. And philosophically speaking, how can you collectively learn if some of the people who want to learn or who want to help you are actually malicious? And this turns out to be a very interesting problem, again, from a theoretical perspective, but also from a practical perspective. So parts of my group have started working on this, and we believe that once we crack this problem, we will really see interesting applications and a lot of interest on it. So if you join the group, you can, for example, join this branch. The examples I have been mentioning, Bitcoin or machine learning, are examples motivated by applications. Let me give you an example motivated by technology. I pointed out earlier that there are two kinds of environments that are typically considered complementary somehow: message passing in a large-scale setting and shared memory in a local setting. But recently, a new technology have emerged and became somehow very, at least is considered to be the future of distributed computing, which is RDMA. You have nodes that even if geographically distant from each other, they can write and read in the shared memory of each other. Sometimes they do that, sometimes they send messages. So it's a mixture of message passing and shared memory. So this is the new technology. And what we have been doing in the group is asking ourselves, can we build better algorithms for distributed computing if we can mix both message passing and shared memory? And we have been working on this with colleagues from VMware and Oracle and other places and Intel to try to come up with interesting algorithms. And so far, we seem to be making good progress in this direction. And we try to be very fast to be the first to propose something theoretically sound and also practically reasonable. So these are three examples of what my group does. Of course, some students typically sometimes come with their own ideas and we try to pursue them. Somehow the main feature or the main characteristic of what we do is robust distributed computing. We are about 15 PhDs, master, postdocs, and we collaborate with people from all over the world, including for former students of the group. And sometimes we work a lot, sometimes we go surfing, sometimes we go skiing. So the atmosphere is rather relaxed. The lab is pretty rich. We have money from several partners. So if you join the group in September, and if you like the group and you like the activities that we're doing, the chances that you stay, if we also like you, are very high. There is no problem of money actually. So in the meantime, I hope that you will stay safe and that you will make the right choice and join EPFL.